Okay, so I had some requests for a few of these lesson problems to go back over, which I think is a great request, so I'm going to go over them. We'll start with number 7 from lesson. This is lesson week 1. It says, how many even factors does 576 have? So we start the same way we've started all these factor problems, which is to do the prime factorization, which 576, if you do your prime factorization, turns out to give you 2 to the 6 times 3 squared. Now, when doing this problem, to find the number of even factors, it's actually easier to find the number of odd factors. Because, when you're looking at factors and you're pairing up these primes, any of them that get paired up with a 2 is going to give you an even number. So it's much easier to get an odd. It has to be just odd numbers. So in this case, this problem, to find the number of odd factors, you just look at the odd prime numbers, which turns out to just be 3 squared, add 1 to its exponent, which means there are 3 odd factors. Because they all have to be just small things that have to do with 3, and the only things they can do with 3 are 1, 3, and 9. Now, the total number of factors, which we know how to do, is if we add 1 to both of those, we get 7 times 3, which is 21. Subtract 3 for the number of odd factors, and that gives us 18 even factors. So the answer is 18. 10, this is a problem we didn't talk about how to do. It says find the largest power of 3 that divides 24 factorial. Well, let's just look at a smaller problem first. Let's say 10 factorial. And what we're doing here is we need to think about how many powers of 3, or how many 3s can divide out of that number. Well, another way to think of it is, if I think about it as a fraction, how many 3s can I cancel out? Once I can no longer cancel out 3s, then I can no longer have that as a power that divides 10 factorial. Well, it turns out, here's 1 3, here's 1 3, here is 2 3s. So you got to figure out how many 3s there are as you go along. And so one way to do it is to find out how many multiples of 3 there are. Well, how many multiples of 3 are there from 1 to 24? Well, that goes from 3 to 24, which would be 8 multiples of 3. But then you also have to consider multiples of 9, because each multiple of 9 gives me another 3. So how many multiples of 9 are there? Well, there actually turn out to be 2, 9 and 18. And so that gives me 2 extra 3s. So the answer to this question is 10, because there are no 27s, which would be 3 cubed. The shortcut is you do 24, divide 24 by 3, that gives you 8. Then you take the 8, divide it by 3, that gives you 2. That goes there. If you divide 2 by 3, that's going to be 0, so you know you're done. And so you just go through and do division. So let's do a couple more using that division. So it says, what is the largest power of 6 that divides 60? Well, you can't do this division based on 6. You have to use the factors of 6. So it's got to be 2 or 3. Okay, you can't just look at it's got to be a prime number to use that method I just showed you. But if you're going to be able to factor out a 6, then it's got to have a 2 in it and a 3 in it. But the 2, there are going to be a lot more 2s than 3s, I think everybody could agree. So all we have to really worry about is how many 3s are in 60 factorial. And so you just do 60, divide it by 3, that gives you 20. So you got a 20 there. 20 divided by 3, that gives you 6. So now there are, remember what that means is there are 6 multiples of 9. And so that means you got a 6 extra 3s from that. Then you divide 3 into 6, which is 2. That 2 tells you there are 2 multiples of 27, which is 3 cubed. So the total number of 3s that can divide into it is 28. Well, if you do 2s, you'd get a lot more. So the answer to this question is 28, because we compare every one of those 3s with a 2 to get a 6. Okay, same thing for 72, except this time it's a little harder because we've got to think about 72 is 9 times 8, which is 3 squared times 2 to the cubed. So I need to find out how many 3s there are and then divide that by 2, because I need to find out how many pairs of 3s there are. And then I need to find out how many 2s there are and then take out how many how many ways can I get 3 2s. So let's just start with 3 first. So we're going to do 80 and divide it by 3. That equals 26. And then 26 divided by 3, that's going to give you 8. 8 divided by, you can just leave the remainders alone on these. 8 divided by 3 is going to give you 2, and that means we're done. So there are 36 3s. Now we need to do 2s. So 80 divided by 2 is 40. 40 divided by 2 is 20. 20 divided by 2 is 10. 10 divided by 2 is 5. 5 divided by 2 is 2. 2 divided by 2 is 1. So what that means is this is how many 2s there are, that's how many 4s, that's how many 8s, how many 16s, how many 32s, and how many 64s. Add all that up and you end up with 78. Remember I said how many pairs of 3s do I have? Well, divide 36 by 2, you get 18. How many sets of 3 of these? Divide that by 3 and you get 26. So I'm going to have 18 9s and 26 8s. So it's limited by the 18 9s to get, because you have to have a 9 to get 72. So the answer is 18. All right, last one set here for this video. Find the number of factors of 9 factorial. Well, this is a problem you know how to do if you learned from the lesson, but maybe what's confusing for you is finding the prime factorization. Well, to do the prime factorization, don't actually multiply it out. It equals 362,880. Way too big a number to try to worry about prime factoring. Instead, you've already got a lot of factors here. For instance, how many 2s do you have? Well, here's 1. There's 2 more. That makes 3. That makes 4. There are 3 there. That makes 7. So there are 7 factors of 2. So it's going to be 2 to the 7th. How many 3s? 1, 2. There are 2 and a 9, so 4. So times 3 to the 4th. How many 5s? There's 1. How many 7s? There's 1. So how many factors? Add 1 to each of these. And you get 8 times 5 times 2 times 2, which equals 160. So there are 160 factors. Now we do the sum of the factors. And remember, when we do the sum of the factors, we take each of the exponents and we count it down and add up all of those, so each of the bases. Now, if you don't know the shortcut for 2s, if you're adding them up all the way down to 2 to the 0, it's always going to be the next 2 power of 2 minus 1. You can go through and kind of look at the pattern of that and figure it out yourself. And so that means that's going to be 255. And then I've got to do the 3s, which is going to be 3 to the 4th, which is 81, plus 27, plus 9, plus 3, plus 1. The 5s and 7s are easy. That's just going to be 1 more than each of those because you're just doing 5 and 1 and 7 and 1. So now I need to multiply all that together. 2 to the 8th is what? 255. So we're going to do 255 times, when you add these together, you get 30, 120, so it's 121, times 6 times 8, which equals 1,481,040. And then the product of the factors, well, product of the factors is easy. Remember, you just take the one of the numbers, which is 9 factorial, which turns out to be 362,880. And then you recognize that every one of these 160 factors is paired up with another one that multiply together to give you 362,880. So you just add that to the 80th power. I know I moved kind of fast through those problems. If you didn't understand them, please let me know, and I can do another video explaining it in more detail. But also remember, you can always rewind and listen again. It might take you 3 or 4 times listening to a certain part to get it, but always go through and rewind if you need to.